The connective tissue includes the embryonic connective tissue, also called mesenchyme, and the adult connective tissue. The adult connective tissue can be loose connective tissue or dense connective tissue. The difference depends on the abundance of extracellular matrix and collagen bundles. Extracellular matrix is prevalent in loose connective tissue. Collagen bundles are abundant in dense connective tissue. If the collagen bundles are uniformly arranged, the connective tissue is called dense regular. An example is tendon. In contrast, dense, irregular connective tissue is characterized by the random arrangement of collagen bundles. Examples are the dermis of the skin and the submucosa of the stomach. Depending on the type of fiber, the adult connective tissue that contains reticular fibers, equivalent to type 3 collagen, is named reticular connective tissue. This type of connective tissue is observed in the stroma of lymph nodes and the spleen. The elastic connective tissue, rich in elastic fibers, forms the layers or lamella of the wall of the aorta. There is a separate category of special connective tissues. Special connective tissues include the adipose tissue or fat, cartilage, bone, and bone marrow. We study bone marrow together with blood in Chapter 6. There are two types of adipose tissue, white adipose tissue and brown adipose tissue. White adipose tissue is unilocular. Adipose cells contain a single lipid droplet that occupies most of the cytoplasm and displaces the nucleus to the periphery of the cell. In contrast, brown adipose tissue is multilocular. Adipose cells contain multiple lipid droplets in addition to abundant mitochondria. There are three types of cartilage: hyaline cartilage, elastic cartilage, and fibrocartilage. Hyaline cartilage and elastic cartilage have a perichondrium, and type 2 collagen predominates in the extracellular matrix surrounding the chondrocytes. In addition to type 2 collagen, elastic cartilage contains elastic fibers in the extracellular matrix. Fibrocartilage is different from hyaline and elastic cartilage. It lacks a perichondrium. And type 1 collagen instead of type 2 collagen is present. There are three structural types of bone: compact bone and cancellous bone. Compact bone is lamellar and haversian. In other words, concentric lamella surround a haversian canal where a blood vessel is present. In contrast, cancellous bone is lamellar, but is not haversian. Concentric bone lamella are observed, but there is no haversian canal. The third type of bone is the woven bone, observed in the developing bone. Type 1 collagen is deposited at random, in contrast to the more orderly arrangement of type 1 collagen in compact and cancellous bone. Remember the main cellular components of the bone: osteoprogenitor cells, or preosteoblasts, that give rise to osteoblasts and osteocytes, and bone marrow-derived macrophages that develop into osteoclasts by the process of osteoclastogenesis.